This video is about configuring IGMP snooping in Commando Marshall C3500 series routing switch. So IGMP snooping constrains the flooding of IPv4 multicast traffic on VLAN on a device. With IGMP snooping enabled, the switch monitors IGMP traffic on the network and uses what it learns to forward the multicast traffic to only the downstream interfaces that are not connected to the interested receivers. The switch conserves the bandwidth by sending the multicast traffic only to the interface connected to the device. That means it receives the traffic instead of flooding the traffic to all the downstream interfaces in a VLAN. So basically it saves the bandwidth in the switch by not flooding everywhere the multicast traffic. So how to configure IGMP snooping? So IGMP snooping can be enabled globally or per VLAN basis. For that you have to go to the configuration of the switch by giving the command config terminal IP IGMP snooping, and if I want to have the IP IGMP snooping in VLAN 1, so for that IP IGMP snooping VLAN 1. So we can verify if the configured IGMP snooping by giving the command show IP IGMP snooping. So this way you can see IGMP snooping is enabled. So the benefit of IGMP snooping is to optimize the bandwidth utilization. So IGMP snooping's main benefit is to reduce the flooding of the packets in the network, and switches selectively forward the IPv4 multicast data to a list of ports that want to receive the data instead of flooding to all ports in a VLAN or in a switch. So this also improves the security, which prevents the denial of service attacks from the unknown source. So this IP IGMP snooping transmit data on demand on the data link layer by analyzing IGMP packets between the IGMP carrier and the user to build and maintain layer 2 multicast forwarding table. This feature allows network switch to listen to the IGMP conversation between the host and the IGMP speaking switch or a router, and by listening these conversations the switch maintains a map of which link needs which IP multicast string. So how the IGMP works? So switches usually unicast MAC address by checking the source address field of the frame, and they receive and send any traffic for that unicast address only to the appropriate interfaces according to the MAC table. However, a multicast MAC address can never be a source address of a packet. As a result, when the device receives the traffic for a multicast destination address, it floods the traffic on the relevant VLAN or the relevant switch networks, sending a significant amount of traffic for which there might not be necessary to be interested receivers. So this IGMP snooping prevents the flooding. When you enable IGMP snooping, the device monitor IGMP packet between the receivers and the multicast ports or the switches or routers, and uses the content of the packet to build a multicast forwarding table or database of the multicast group and the interfaces that are connected to the members of the group. When the device receives the multicast packets, it uses a multicast forwarding table to selectively forward the traffic to only the interfaces that are connected to the members of the appropriate multicast group. So IGMP uses various messages like general query, group specific query, group and source specific query, and the host that are multicast listener send the messages like membership report, leave report, and so on. So we can configure various things. We will start with configuring a fast leave. When a IGMP snooping fast leave is enabled, the IGMP snooping group will be removed at once upon receiving a corresponding IGMP report. Otherwise the switch will not send out any specific IGMP specific query. If this does not get response on the specified period, it will remove the group. By default, IGMP snooping fast leave is disabled globally. You can see that on switch or on the VLAN. So I will configure the IGMP. So for that, fast leave, configure terminal, IP IGMP snooping fast leave, or if I want to on particular VLAN, IP IGMP snooping VLAN 1 fast leave. So I can verify this fast leave configuration by giving the same command, show IP IGMP snooping, and you can see now it is enabled. We can also configure the query parameters. So you can go for many of the query parameters. I will show you how to configure that. Config terminal and IP IGMP snooping. So you can have the various parameters like query interval. You can set the query interval as per your requirement. Let us say I want to have the query interval 100. We can also have the query max response time. Let us say 5. We can have the last member query interval. So last member query interval, we can have, let us say 2000. We can also have various last member query count also we can have. So various parameters can be configured. So you can set this count from any of the count value. Default is 2, I want to have 3. So this way you can configure the query parameters in your switch, and you can verify these things with the help of show IP IGMP snooping, and you will come to know about the IGMP snooping status of your device. Show IP IGMP is a command, and you can see the groups, interfaces and snooping. So I can see the interfaces by giving the command interfaces and enter. So I can see the interfaces. So now interface VLAN 1 is having the IGMP inactive with version 2 by default, and this is the IP address. So I can go to that interface and can enable that also. So configure terminal, int VLAN 1 IP IGMP snooping version 2, or any of the version as such. I can have version 1 to 3. I want 2. Default is 2. So this way we can enable the IGMPs in that particular VLAN or particular interfaces which we want to have, want to configure. We can also have the parameters configured like IP IGMP snooping, and we can have this discard unknown. So this will help us. So to discarding the unknown things, we can also use the fast leave which we have already configured, and we can have the max member number. So this is also a very important parameters in snooping. Max member number. Max member number. And we can give the parameters. Max allowed member number on a VLAN interface default is 2048. I can reduce to 10. And whatever changes I have done here in the global configuration can be seen by the command show IP IGMP snooping query. So you can see that this snooping configuration, I have configured the version 2, the last member query, and other parameters whatever we want to have. We can configure the M router port with a switch port which is assumed to be connected to the multicast router or multicast speaking other switch or the other capable router. The mroute port is configured on a VLAN or learned dynamically. When IGMP general query packets or PIM version 2 hello packets is received on the port for specific VLAN, this port become a mrouter port of that VLAN. All the IGMP queries received on this port will be flooded on the below VLAN. All the IGMP reports and the leave received on this VLAN will be forwarded to the mroute port directly or aggregated depending on the report suppression configuration. In addition, all the multicast traffic on a VLAN will be forwarded to the mroute port. So for that we will configure a mroute port. So configure terminal, IP IGMP snooping report suppression, then IP IGMP snooping VLAN 1, because I am having one VLAN in this, mroute router interface ETH-0-9. ETH, let us say I want to have 13. I can have this VLAN 1 report suppression also. VLAN 1 report suppression, and I can have this IP IGMP mroute aging interval also. Mrouter aging interval, let us say 300 seconds. So show IP IGMP snooping VLAN 1 will show the configured things. We can have the TCN query. This will support to adapt and multicast router learning and updating after STB conversions by configuring this TCN query count and query interval. So for that, configure terminal, IP IGMP snooping query TCN query count, let us say 5. Then query interval also I can have query interval 20 seconds. And by giving the command show IP IGMP snooping query, we can find out the configured things. We can also configure static groups also. So a switch can build the IGMP snooping group when receiving IGMP report packets on layer 2 port of a specified VLAN. We can also support configure static IGMP snooping group by specifying the IGMP group layer 2 port and VLAN. So for that, configure terminal IP IGMP snooping VLAN 1 static group, let us say 229.1.1.1 is the IP address with interface ETH-0-2. So I can configure this show IP IGMP snooping groups. So you can see this group which I have created. We can also configure IP multicast routing command to enable IP multicast routing. So for that, the command is configure terminal IP multicast dash routing, and the IP multicast route limit also we can have. So maximum number of the multicast route, default maximum number of multicast route is 2048. This default threshold can be same as the maximum number of multicast routes. So I can change that. So IP multicast route limit, and we can have, let us say, 512. By giving the command show IPM route, will give the routing table. If other router is configured, this will come active, and we can also see the show IPM route summary. We can see the show IPM VIF. So if it is configured on other router, it will be shown, and show resource mcast. So this will show the capability and the resources used by this. So how a host or a user or the PC or the laptop joins and leave multicast group? So host can join the multicast group by two ways, by sending the unsolicited IGMP join messages to join the multicast router that or switch that specifies the IP multicast group the host wants to join, or by sending IGMP join messages in response to general queries from the multicast router. So multicast router continues to forward the multicast traffic to the VLAN provided that at least one host on that VLAN respond to the periodic general IGMP queries. For a host to remain a member of the multicast group, it continues to respond to the periodic general IGMP queries. Host can leave the multicast group in either two ways: by not responding to the periodic queries, and secondly by sending a leave report. So this way it can do. The layer 2, 3 or multi-layer switch can use IGMP snooping to constrain the flooding of multicast traffic by dynamic configuring layer 2 or interfaces, so that the multicast traffic is forwarded only to those interfaces associated with the IP multicast devices. So this IGMP snooping is a very important tool to constrain the flooding inside your network and save your network from multicast storms. Thank you so much for watching this video. Thank you.